Okay, in this video we'll talk about the state space system. Alright, just to give you an analogy first, is that if you remember your analog system, your state space is all this thing. If you do not recognize anything about this thing that I'll just show you, this whole chunk, alright, I recommend you go to control female playlist of this channel, alright, and then you go and look out for l10v3, alright, talking about state space and setting up the state space. Okay, so therefore I'll just continue with this thing, taking in consideration that you have understand this. If you don't understand, I will not recommend you watch this video. Okay, those first. Alright, in the analog domain, alright, your A can be represented by a matrix, your B, C, and your D also can be represented by a matrix, because you're talking about multi-input, multi-output. Alright, so this you're feedbacking a lot of state, or not just a single input, single output. Alright, so be careful of these things. Alright, so everything is in terms of an analog. So if you were to write in terms of a digital domain, things will be a little bit different. Okay, so how is it different? Is that, right, this thing, maybe I should bring it, hold on a while. This thing over here is your analog, alright, because it's x dot, meaning x dot t in terms of time domain. Alright, same thing over here. This thing over here is still the time domain. And in fact, this thing is exactly the same as this. Nothing is different. The only thing that is different is only the symbol. A I change to F, G I change to B. Because I don't want to confuse you that in the analog is analog. Alright, in the digital, because this is still analog. But later on we're going to use this information to transform it to a so to speak, the discrete domain. Alright. So over here in the discrete domain, we want to use a certain information from the analog system. Alright, so they are closely linked together as one. So therefore I don't want to confuse you with this and this thing all together, because I just want to define to you, once you see these symbols, alright, you will know straight away that you're talking about discrete or digital state space. Okay, say discrete state space lah. Alright, and therefore please take note that this thing over here is exactly the same. I just changed the name only, that's all. The name is different, but the quantity and everything, the matrix is different. For example, if A is 1001, F is also the same thing. Alright, because I just simply changed the name, and I just want to let you know that they are just I write this is because I want to show you that this thing belongs to the discrete system. We're going to use the information from here in here. That's all it is. Okay, so next is I just want to inform you that your x dot I rewrite as xk plus 1. Okay, your y I write as yk. Okay, because remember the Eulers formula. Alright, you're going to take a k and maybe your past information k minus 1 etc. all the way to its back. The all information, if you don't understand what I'm drawing right now, I'm actually drawing a signal. Alright, a signal. So these are all discrete points, k minus 3, k minus 2. So this thing over here, so the current input, so to speak, with plus the previous output, it will give you your new system, new output. Alright, so this thing over here is equals to this thing. If you were to just summon out all together, you'll get k plus 1. Right, this k plus 1 you can rewrite as yeah, that will be better. So your xk, alright, instead of k I just write as xk, alright, plus its own previous information will give you your next information xk plus 1. Okay, so this xk plus 1 you can rewrite as x dot. Okay, so it's the next information. Alright, the next information. That's why I just don't want to confuse you with the information of the analog system. Analog is the differentiation. Alright, it's differentiation of x. It's slightly different. Alright, where this x dot over here in the discrete system, although they are the same, alright, but the definitions is a little bit different. X dot over here is telling you that it's xk plus 1, the next time step of your signal. Okay, so I hope that you understand. Alright, likewise if it's y, then you just simply rewrite as yk, that's all, because there's no time step further forward or backward, things like that. If you don't understand anything about forward and backward and all these things, you can watch the playlist. In this playlist you can watch the Eulers, this L2 stuff, lesson 2. Alright, or nonetheless you can also watch L6. L6v1 to better understand how to do Eulers forward and backward and testing, or how to transform the Laplace domain of them and things like that. Alright, so I'll leave you to there, but let's come back to here. Okay, so over here we have somewhat tell you or inform you that this thing over here is your analog system. It's still analog, but the definitions of this x dot is equals to this thing is equals to this. Likewise for all this, alright, it's a little bit different already. For the xk, this is all vectors. You see, there's an arrow over here. There are vectors. Okay, this is also vector. While your this things over here aren't vectors. Okay, I think this is also vector. Okay. But if you think about it, alright, this portion over here, alright, this x and this x is a bit same as this point. Your u and your u is also the same as uk. Alright, so I'll just simply transform all the time domain into the discrete domain only. Okay, while your f now is being utilized as this coefficient over here. Alright, what this phi is equals to e to the power ft. Alright, while this gamma, capital gamma, alright, is in terms of f and in terms of g. Alright, so I'm using information of the time domain into our discrete domain. Okay, so these are all things that is being given to you. You just need to memorize, and that's all. Okay, and I should say is this one. This thing is a discrete. This is a discrete of this thing. Alright, while you use the information of the f and the g to help you compute your stuff. Alright, over at this side. While your h and your j are the same all over here. You don't need to care too much. Okay, so these are the things, and that the transfer function, if you remember, the transfer function for the analog system is this thing. If you find it familiar, if you don't find it familiar, you can just head back to the control female playlist that I'll show you in the lesson 1v4, lesson 1 video 4. Alright, you can just watch the video on state space, and eventually you'll see that this is a transfer function for analog system. Now, likewise, for the discrete system, or digital system, your transfer function is in terms of this thing. Alright, in terms of your all this stuff. Okay, so these are the things that you may want to understand. Alright, want to see the similarity, the C is over here. Alright, while your A is over here, your B is over here. Same thing. Alright, for this thing, your H is over here. Alright, this is like your C like that. You see, you compare. Correct? And then your B is over here. Yeah, this is R. Okay, this is your gamma. Alright, your B, this thing over here is this thing. Your gamma is over here. Just compare. Okay, while your this thing, your phi is over here. Is this thing your A. Right? So you don't know, if you don't know what I mean, is that this thing over here, alright, is very similar to A, B, C, and D. Okay, like this thing, but it's in terms of a different name lah. Okay, but I just want to show you the similarity of the transfer function with this thing and this thing. So if you happen that you forgot this thing, at least you can, if you remember this thing, you can actually rewrite in terms of here. So at least you can still help yourself. Okay, things like that. For this is the definitions of your state space in the discrete domain. Alright, so in the next video we'll use these definitions, alright, to actually help us to derive a certain transfer function in the Z domain. Alright, where we talk about trying to prove to you that the state space answer, alright, will be the same as when you have Z transform your certain transfer function. Alright, so this thing over here will be the same as this, will give you the same outcome of your Z transform answers. Alright, so therefore in order to understand the state space, in this video I'll give you the definitions. So in the next video I'll do up the state space to show you, and eventually to prove to you that it is, because I think the definition is very important. Alright, so this is why I'm writing it in terms of all this, to give you the comparisons and let you to understand everything. Alright, so see you in the next video to do up the example that we have last stopped.